2.2 Limits involving infinity. The symbol infinity, which is like a sideways 8, is not actually a number. It describes a behavior of a function. When we say the limit of f as x approaches infinity, what we mean is the limit of f as x moves increasingly far to the right forever, and vice versa for negative infinity. So again, what that means is we're letting x get insanely large. So instead of looking at x equals 100 or x equals 10,000 or x equals 10 to the power of 100, we're looking at numbers that are just too giant to describe, and so we call that infinity. Another way to think about it is if you can think of a number, I can think of that number plus 1, or that number times 10. There's always a larger number, and so that's what we're describing with infinity. The same works for negative infinity, just in the opposite direction of the x-axis. So we're going to look at the graph of f of x equals 1 over x on your calculator, and we're going to look at the behavior as x approaches infinity. So if we look at our calculator now, we're going to graph 1 over x. So you push y equals, and the trick to do fractions is you're going to go ahead and push the green button alpha, and then you're going to push the y equals for f1, and that's going to give you this chart, and then you're going to push n/d, and that generates the fraction symbol for you. I know for 1 over x, it might seem easier just to do 1 divide x, but for more complicated functions, this comes in handy. So we're going to do 1 divided by x, and again, the x symbol is the one next to alpha. And so now you go ahead and hit graph, and your graph should look something like this. And we all know what 1 over x looks like. And now what we can do is we can zoom in or zoom out. So to zoom in, you push zoom, and then you push 2 for zoom in, and push enter where you want to zoom in. And so we can see what happens when we're close to 0, but we're more interested in what happens when we approach infinity. So we're going to actually zoom out a couple times. And we'll do that again. And as you can see, it's just this blue line right here. So this is kind of hard to see on the calculator, but it looks like it just becomes 0. So now I'm going to show you on a more advanced graphing feature what this actually looks like. So this is 1 over x, very zoomed in. And now what I'm going to do is I'm going to go ahead and zoom out for a while. And as you can see, we're only zoomed out to 260, which isn't a large number compared to infinity. And you can already see how the graph, as x goes to infinity, the y value becomes 0. So we call that an asymptote of y equals 0. So we call that an asymptote at y equals 0. And if we zoom in again, you can see the asymptotes start to be true pretty quick. And so we get this asymptote right here, and I recommend you draw these graphs in your notes. You get an asymptote right here of y equals 0. And again, this is the zoomed in version. And then this right here, this is the zoomed out. So you can see the asymptote occur right here at y equals 0. So, after we graph it, we're going to write, as x approaches infinity, 1 over x approaches 0. And that's what we just saw. So to write that as a limit, we write the limit as x approaches infinity of f of x equals, so the limit as x approaches infinity, f of x, which is this piece, approaches 0. And for part B, as x approaches negative infinity, 1 over x also approaches 0. So we write this is the limit as x approaches negative infinity of f of x, and the limit of negative infinity is 0. So this shows that the line y equals 0 is the horizontal asymptote of f. So we can call something an asymptote when we let the limit go to infinity or negative infinity. So now let's actually get the definition of a horizontal asymptote. So the definition, the line y equals b is a horizontal asymptote, and for short, we just write that as HA, of the graph of a function y equals f of x if either the limit as x approaches infinity of f of x equals b, or the limit as x approaches negative infinity of f of x equals b. And an important side note to make is that a graph can have more than one horizontal asymptote. And we will look at examples later where we have multiple horizontal asymptotes. It's also important to note that functions can actually cross horizontal asymptotes. They only converge to them as x approaches infinity. So near 0 or 5 or 10, they can actually cross these asymptotes. It's only as we look at the graph near infinity or negative infinity.